So you guys just found all those. We're going to go through. We're going to do number one. Gosh. We're going to do number 1, and we're going to do number 3, and you guys will have the responsibility of doing number 2 and 3, or 2 and 3. We're going to do 1 and 4. So with divisibility rules, we're going to do number 1 right now. Ooh. We're going to go blue because it's not a color on the page. So we're going to go 111. Things that we have to think about for divisibility. Now, divisibility helps you realize sooner and faster what can go into other numbers. Also, you can pull out different numbers, and it'll help you get some of the math facts done sooner. Excuse me. So with 111, things you have to ask yourself as you go through mentally with the divisibility rules that you just wrote in your notes from your book. So with 111, is it divisible by 2? One of the questions you need to ask yourself. No, I see you shaking your head. No, you are correct because it is not an even number. Now, I'm going to shoot through this really fast, class. I'm sorry, but we do have to get through all of it, especially because other classes didn't. So this one here is not divisible by 2, so I'm not going to write 2. Then we have 3. The divisibility rule that you wrote down is that it is the sum of the integers is divisible by 3. 1 plus 1 plus 1 is 3. And is 3 divisible by 3? Yes. Boom. 3. Then we try 4. 4 doesn't work because it has to be an even number, and the two last digits, the 10s and the 1s, has to be divisible by 4. 11 is not divisible by 4. For 5, it doesn't work because it has to end in a 0 or 5. And for 6, it doesn't work because it has to be divisible by 2 and 3. And for 10, it doesn't work because it has to be ending in a 0. Okay? So that's it. Just 3. That's the only divisible by 3. Okay? Number 4, we're going to jump over here. Things we have to consider. Is it divisible by 2? Yes, because it is an even number. So I'm going to write down 2. Is it divisible by 3? Let's do the sum of the digits. 2 plus 4 is 10. No. 6. Plus 6 is 12. Plus 4 is 16. Does 3 go into 16? No. No, so it's not 3. Okay, 4, is it an even number? Yes. Is the last 2 digits, 4 and 0, is that divisible by 4? Yes, 4 times 10 is 40. So 4 is one of them. Then we have 5. Is it divisible by 5? Is it a 0 or 5 in the 1's digit? Then yes, it is. How about 6? Is it divisible by 2 and 3? No, so it's not 6. Is it divisible by 10? Yes, because it's a 0 in the 1's digit. So I expect you to do this one and that one on your own. Nope, not right now because we got to keep trucking. Okay? Got to keep trucking. Now, divisibility rule for 9 is very similar to the rule for 3. Can you figure out what it is? What do you think it is? Yeah, it's the exact same thing. But if the sum of the digits is divisible by 9, then it is divisible by 9. Okay, so that's what you're doing. Sum of digits. Sum of digits divisible by 9. So is the number. You know what, I kind of want to experiment with that a little bit. Okay, let's experiment with that a little bit. Let's see if this holds true. All right, so let's think of a number that we're going to get up to the sum of 45, because 45, do you agree, is divisible by 9? Okay, so because it's 9 times 5. Now, let's get single digits that add up to 45, okay? So, Harrison, give me a number. 7. Okay. Elena, give me a number. 3. Okay, now we have 10. Good. Charlie? 8. Lena? 9. Okay, so what are we at right now? We're at 10. Okay, we're at 27. No? 18, 27. Yes, we're at 27. Okay, we need to get to 45. 11. Nope, that has to be one digit. 9. Okay, we already used a 9. Let's try something else. 7. Oh, that works. That works. That's fine. That's fine. We already used 7, but I don't want to use the same number that we're looking for. Okay. Sydney, you got one? 5. Okay, so we got 10, 19, 27, 34, 39. So what is left? 6. So we can find out if 7,389,756 is divisible by 9. It should be. Let's test it out. 7,389,756 divided by 9. If we did this correctly, it should be a whole number. It's a whole number. Yep. Okay. If you guys are done with the test, go ahead and put it on the other test there. Okay. Good. So that's experimenting with that divisibility rule that you just came to find out or figure out. Okay. Now with this one here, a monomial is in section 4.2. Okay, section 4.2, and I'm going to give you that definition right now because did you see, it's the test that looks exactly like your test. Yes. There we go. All right. Well done. All right. The definition of a monomial. Did you guys get these notes? Okay. Where are we? There we go. Is an integer a variable or a product of integer? A product of integer. An integer, a variable, or a product of integers. A product of integers or variables. So is the integer a variable or a product of integers / variables? A monomial may not include addition or subtraction. That will make it not a monomial. Because when you're adding or subtracting things to each other, it can't become one, and mono means singular. You with me? Okay. Then there's this part. This is big. Does not include addition or subtraction, okay? So, circle the terms that are monomials. Is 2x a monomial? Yes, because it's a product of integers. Okay, 1/2 is it? No. Do you see addition or subtraction there? No. So yes, it is. Exponents are as well. How about this x plus 5? No. How about negative 4b? Yes, it is. So a lot of you yesterday, for some reason, created this thing that where a negative number is a subtraction sign. No. It's not a subtraction sign. Okay? How about this guy? No, because it has a subtraction. Then that one is yes. Okay? We're going to shoot through these as well because we need to. All right? Same situation, but now we're going to say the reason it is, the reason it isn't. We have m. Is that one? Yes, because it is an integer or a variable. It is a variable of an integer. Negative 7. Yes, it is. It's an integer. Do you see a plus or minus in there? No. Forget about it. How about number 3? That one is not because it has a subtraction. Whoa. Whistled. Okay, subtraction. 3 divided by 3v, or 3 over 3v. Yes, it is. It's a product of variables. Okay. You know what? I'm going to skip those, so this is your guys' responsibility to complete that much. Okay? And you'll probably get to it as soon as we get through what we're going to do now. Okay? So this is the part that the earlier classes didn't get to, and I want to get through this. Then you guys can do your hopefully get your homework. All right. 4-2. 4-2. This is about powers and exponents. Powers and exponents. It says here, is 2 cubed the same as 3 squared? Okay. Why? I'm going to tell you and agree with you, no, it isn't. That's because 2/3 equals 2 times 2 times 2, which equals 8. Semicolon. 3 squared equals 3 times 3, which equals 9. Whenever you have an exponent, which is that number that's kind of hanging on the back of that number, so when 2 cubed, where it's 2 and then a 3 high, the 3 that's hanging out getting a piggyback, that says that the base is going to be multiplied by itself 3 times. Not multiplied by 3. Don't think that this is the case. 3 squared, no, not that. 2 cubed equals 3 times 2 times 3. No. Okay? Well, I just need to do this then. Because I got to do it really small to do that. It's a very, you know how I fail so often? It has to be a very specific arm movement. Okay, yep, and you have to be nice to it as well. You have to ask it, please. Now, the product of the same factor here, this means it's just get written out all biggie. All big, long. Product of the same factor. So if we were doing 5 to the 9th, or the power, 5 to the 9th power, what we would have is 9 5s. So write that. Yep. Pi. Go ahead and put it on the other tests on my desk. So you should have 9 5s there. 9 5s. Was absent 9 times. That's a Ferris Bueller reference. Okay? Yep. What is the value? What, don't you get? This? It was when principal calls and says how many times he's been absent. He was absent 9 times. Yes, ma'am. 175. Is that what you said? 125. Good guess, but no, actually, it's almost 2 million. This I'm going to show you how to use this. Even though you don't use calculators much in this class, I'm going to show you how you do it. You write 5. You hit 5 on the calculator. Then you hit a button that is X. No, it's actually Y. Y to the X. No, I don't get out your calculators. I'm showing you how to do it. You're writing that down. 5, Y to the X, 9. And the correct answer is, let's see if I can remember off the top of my head, 1,531,129. Let's see here. Let's see if I get it. Okay, 5, X to the Y, 9 equals 1 million. Oh, 1,953,000. 1,953,000. 53,125. Okay? That's how you do that. Now, since the exponent is showing what is being done how many times, it's being multiplied by itself how many times, if we have parentheses here, like we do here, it is saying that x minus 2 is going to be multiplied by itself how many times? 3. So let's write that out. It's going to look like this. X minus 2 times x minus 2 times x minus 2. Nope, it was just 3. I was playing the skipping record game. So now, please excuse my dear Aunt Sally, order of operations really is important. For the next two questions especially. So, questions? Okay, knock them dead. See you guys. Good luck. All right. We have evaluate the expression m. Fellas, question? Question? No? Okay. We have m is 2, n is 3. So we have 2 times 3 cubed. Okay? What is the first thing we need to do through order of operations on this? Yes?
Well, no, I don't have
Okay, hold on. You can ask me that question in a second. Yep, I haven't made a mistake up there yet. So, what's the first thing we do? Go for it. What do you think? I see what you're saying. Okay, that could work. What if we wanted to focus on what it says on the order of operations, though? What is the first thing we need to do with order of operations? Yes? Is it excuse my dear Aunt Sally? Or is it please? Parentheses. But you may just be thinking ahead. Do you see parentheses there? No. So we do the exponents first. Thank you. So what is 3 times 3? 9. What's 3 times 3 times 3? 27. Good. And I'm going to represent that using parentheses. 27. And 27 times 2, because we're not in 4th grade anymore, is 54. Okay? 54. Now we do have parentheses this time. This time we do have parentheses. So it's going to be something very similar, but now we have parentheses. 2 times 3 to the third. What do we do first? Charlie. Parentheses. So we have 6 to the third, 6 cubed, as we say. And 6 times 6 times 6 is what?
211.
Close. 216. Okay? Okay, teaching moment here. I'm going to show you how you can find that really fast using the distributive property in your head. Okay? If you break this down, because you know that 6 times 30 is going to be simply 180, right? Right? Sure, you should know that 6 times 3 is 18, and you add a 0, it becomes 180. Then, by order of distributive property, we still have 6 sixes to take care of. So 180 plus 36 is what? 216. Like that, without even using a calculator. Yes? 8 times 8 on the top of my head. You all should know that, and I had better know it. Yeah, but I appreciate the challenge, but yeah, we should all know it off the top, especially the double numbers. Those are easy. Okay? Okay, we shouldn't even need to think about those. All right. This one here, evaluate the expression. Ignore this, that's a typo.
You scribbled out your own scribble.
Okay, I did scribble out my own scribble. Okay? There. 3jh to the 6th. So I'm going to substitute 3 times 4 times I. What? That's a 1. 1 to the 6th. Now, we have to do exponents first. So we have to do 6 times where 1 is being multiplied by itself. And 1 times 1 is what? 1 times 1 times 1 is what? 1 times 1 times 1 times 1 times 1 times what? 1. Triangle. Correct answer. Okay? So we have 3 times 4 times 1, which equals 12. Okay? Next one, write 5 squared using an exponent. I've been saying it throughout these last 7 questions. What is 5 squared? 5 to the 2nd power. Good. Okay, how about p cubed? P to the 3rd. That's right. P to the 3rd. All right, let's see if we can get through this in 6 minutes. Okay. Now, expanded form. Expanded form is just adding numbers in their digits with zeros on the end, essentially. So the standard form is the way that normal people think, but we mathematicians here can also write it in expanded form by using place values to write the value of each digit number. This can be written with or without exponents. Here it is without exponents. We have 1 in the 10,000s digit, so that becomes 10,000. We have 2 in the 1,000s digit, that becomes 2,000. We have 4 in the hundreds digit, that becomes 400. You following me? Yeah. Now I know this is not new to you. Well, it shouldn't be, I don't think. Okay? Then we have 90 in the 90s digit. What? 90, or 9 in the 10s digit. Goodness. Okay? Which is the same as, once again, we have a situation where 1 times 10,000 is 1, right? Okay? 2 times 1,000 is, what color is that, pink? So 2 times 1,000 is 2,000. To skip ahead a little bit, whenever you see, let's see if we can zoom in a little bit here. Whenever you see an exponent like this, when you see 10 to a power of something, think of it like this. This is how many zeros are at the end of this number. So 1 times 10 to the 4th has 4 zeros, making it 10,000. 2 times 10 to the 3rd is a 2 with how many zeros? 3, which is what number in standard form? 2,000. 2,000. Whoa, boy. Whoa, sorry. Okay, epilepsy warning. Okay, then we have 6. Well, we've done there's with 1 0. Here is 6 times 10 to the 0. If you multiply 10 by itself 0 times, you have the number 1. Yes. Yes. Because you have an integer, you're doing something to it. But if you multiply itself by itself 0 times, not multiply by 0, because that becomes 0. Okay? It becomes just that integer. Ugh. What's that? Don't confuse multiplication identity of 0. Now, with writing this out in expanded form, we're going to do it with exponents because that's faster, and I want to end this YouTube video and get you guys your homework. So we're going to do it with exponents because that part's a little bit more tough, I think. First thing we have to look at, is what place is this 4 in? It's in the 100,000. So How many zeros would there be here if we're doing exponential form? 5. So we're going to do 4 times 10 to the what? 5th power. 4 times 10 to the 5th power. Plus, what's our next integer? 8. And what place does it hold? It's in the 10,000th place. How many zeros after in the 10,000th place? 4. Times 10 to the 4th. Every single step, every step you take will be the exponent is going to reduce by 1. That was the whiteboard. And dear Aunt Sally doesn't need to be excused. Okay. Now you get it. Okay. Next one is going to be, do we need to have this one for 0? Can we do this 0 here? No, because what happens when you multiply something by 0? It's 0. Okay, so then we're going to go down to the 100th spot, times 10 to the 2nd. Same situation, we can't multiply by 0, so then it is 6 times 10 to the what power? No. Because look, we're talking about this, the 0. There you go. Good. Your homework is this sheet of paper, both sides, odds. This one? What should it be? How do you get just the number 6? How do you get just number 6? Abby, ask now. And you have to finish the homework. And you have to finish the notes. I'm going to turn this YouTube video off. Thanks. It's been a time. Okay, let's have an organized goodbye. 1, 2, 3. Goodbye. Okay, there's some.